everyone, in today's lesson we're going to learn how to write ionic equations. Now before we write ionic equations, we must first have a balanced chemical equation. So let's start by writing our balanced chemical equations for the three examples here. So starting with our first example, iron. Iron is a metal, so it exists in the solid state. I'm going to react with nitric acid. So this is an acid-metal reaction. Now all acids have the state symbol AQ, aqueous, and I would form salt and hydrogen gas. So the salt that I'm forming is iron 2 nitrate, iron 2 ion is Fe2 plus, nitrate ion is NO3 minus. So iron 2 nitrate will therefore be Fe bracket NO3 2, and since all nitrates are soluble, iron 2 nitrate will be in the aqueous state. Plus hydrogen gas, so it's H2 in bracket gas. So this is my chemical equation with state symbols. However, it's not balanced because I have two nitrate ions, but I only have one nitrate here. I have two H, but I only have one H here. So to solve this issue, it's easy. All I need is to put a 2 in front of my HNO3. Now it will then be balanced. I'll have the same number of atoms on both sides of my equation. Now let's talk about writing ionic equation from this step. Now for ionic equations, there's a few things to take note. Firstly, for things that are in the solid state, gaseous state, and liquid states, they do not dissociate in terms of its ions. So they are going to stay exactly the same as they are. We can only change those in the aqueous state to write it in terms of its ions, so that we can then identify what are the spectator ions. So I'm going to rewrite these things that exist. Fe in the solid state, and it's going to give me H2 in the gaseous state. This doesn't change. What changes are those in the aqueous state. So we're going to rewrite those in aqueous state in terms of its ions. So if it's 2HNO3, it means I have 2 H plus ions and 2 nitrate ions. So I'm going to rewrite it as 2H plus aqueous plus 2 nitrate ions in the aqueous state. And for my product, iron 2 nitrate, I will rewrite it as Fe2 plus in the aqueous state plus 2 nitrate ions in the aqueous state. So by writing it this way, it allows me to identify whether there are similar ions on both sides of my equation. So if there are similar ions on both sides of the equation, they are known as spectator ions. So you will realize that nitrate ions are present on both sides. So I can actually cancel them, and my final ionic equation would therefore be Fe in the solid state reacts with 2H plus in the aqueous state, giving me iron 2 ions and hydrogen gas. So this is my ionic equation. Now in exams, when they ask you for ionic equations and they give you only one line, this should be your answer. Do not write this as your answer. So this should be your working, that you should write it down somewhere else. Okay, so that's for question 1. Now let's take a look at question 2. Question 2 shows you hydrochloric acid plus sodium hydroxide, giving me sodium chloride and water. So let me write out the chemical equation very quickly. So hydrochloric acid is HCl in the aqueous state plus sodium hydroxide, that's NaOH, in the aqueous state because they are all soluble. And it's going to give me a soluble salt, NaCl aqueous, and water, H2O, in the liquid state. Okay, now with this is already balanced. So I'm now going to write the ionic equation. So for the ionic equation, similarly, I cannot change those that are in solid, liquid, or gaseous state. The only thing I can do is to split the aqueous state in terms of its ions and rewrite it in terms of its ions. So I'll now have H plus HCl aqueous, means that it's going to exist as H plus, and Cl minus in the solution form. NaOH will be Na plus and OH minus. So you do notice that all the state symbol stays the same. And I'm going to form NaCl in the aqueous state, which is basically Na plus aqueous and Cl minus aqueous. And I'm going to keep my H2O liquid. So after I rewrite them in terms of its ions, I can now look for spectator ions. So spectator ions, once again, are the ions that remain the same before and after my chemical equation. So if you look closely, Na plus is here before and after, Cl minus is here before and after. So what really happens in my equation is that the hydrogen ions are reacting with the hydroxide ions to form water in the liquid state. Now this is also known as the neutralization reaction. So actually, if you are very clear with neutralization, you know that neutralization reactions is when the hydrogen ions react with the hydroxide ions in a solution to give water. So actually, if you can recognize right from the start that hydrochloric acid plus sodium hydroxide is an acid plus alkali reaction, it's also known as neutralization, you can actually skip your steps of rewriting out the aqueous solutions in terms of its ions and give me this equation straight away. But of course, if you are unable to see that right now because you don't have enough experience, it is perfectly fine. You can do it step by step to obtain your Ionic equation. So similarly, when it's in questions, only give me this final line because this is your answer. Okay, do not show me your working. Okay, let's do one last question. Copper 2 oxide plus sulfuric acid gives me copper 2 sulfate plus water. Now copper 2 oxide is CuO in the solid state. Sulfuric acid is H2SO4 AQ. Copper 2 sulfate is CuSO4. It's in aqueous state. And water is H2O in the liquid state. So I cannot change solid, I cannot change liquid, I can only split out aqueous. Okay, now if this is my line, let's practice writing our working below instead. Okay, so CuO solid, I'm going to keep it as CuO solid plus H2SO4 in aqueous state. I'm going to split it out. So H2SO4 means I have two H plus ions and one SO4, 2 minus ions. And it's going to form Cu2 plus ions and SO4, 2 minus ions plus water in the liquid state. I cannot split it up in terms of its ions, so it's going to stay the same. Now look out for spectator ions. So what remains the same before and after my equation? I notice it's SO4 2 minus. So I'm going to cancel that off. My final Ionic equation would be CuO in the solid state plus 2H plus aqueous, giving me Cu2 plus aqueous plus H2O in the liquid state. Okay, so that's all for writing Ionic equations. Please do practice and you'll get better at it.